Hey class, Mr. Ganji here. For today's lesson, we're going to be taking a look at section 10.1, which is going to deal with proving the slope criteria for parallel lines. Now, for today's lesson, we're going to take a look back at this concept of parallel lines and what we know about their slopes. And we're going to use that idea of the slope criteria for parallel lines to help us answer our two learning goals for today. So our first learning goal for today is that you will be able to prove sides of parallelograms or trapezoids are parallel using the slope formula, or you will be able to find the missing coordinate of a parallelogram. So we have two different things we're going to look at today. The first one is proving that sides of either parallelograms or trapezoids are parallel to each other. And then we'll also go through and find a missing coordinate value of a vertex of a parallelogram. So let's go ahead and get into our stuff for today. The first thing that we need to look at to refresh our memory is that the slope criteria for parallel lines. And this criteria states two non-vertical lines are parallel if and only if they have the same slope. So back in section 2 or 4.5, we talked about two lines are parallel if they have the same slope. And that's what we're going to remember today, that two lines are parallel if and only if they have the same slope. So when we go through and prove today whether two lines are parallel, all we need to do is just identify if they have the same slope. And if they do, then we know that the lines are parallel. So, same slope, parallel lines. That's what we're going to use to help us answer our questions for today. So, example 1 is going to ask us to show that each figure is the given type of quadrilateral. So for part A, they want us to show that ABCD is a trapezoid. And the thing that we know about trapezoids is that they have one pair of opposite sides are parallel. If we look at our diagram for ABCD, we see that AB and DC need to be the two lines that are parallel because BC and AD will eventually and pretty quickly cross if they were to continue on. So whenever you are asked to prove that a shape is a trapezoid, you need to show that one set of opposite sides is parallel, whereas a parallelogram, you need to show both sets of opposite sides are parallel. So for A, it's a trapezoid. What we need to figure out is if AB is parallel to DC. And the way that we're going to do that is show that they have the same slope. So we need to go through and figure out the slope of AB and DC, and that's how we're going to start our problem for example 1, part A. Now, there's a couple ways we can find slope. The first way and most common way to find slope is through the slope formula. And just to refresh your memory on the slope formula, that is y2 minus y1 over x2 minus x1. So we can use the slope formula to find the slope between 2 points, and that's how we're going to go through and find the slope of AB and DC. Now, your first step in doing these is to go through and identify the coordinate values of A, B, C, and D. So for A, it's at negative 1, 1. Then B is going to be at 2, 3. C is going to be at 3, 1. And then lastly, D is going to be at negative 3, negative 3. So we have successfully gone through and found all of our coordinate values for the trapezoid. Again, to prove this is a trapezoid, we need to know that AB is parallel to DC. So we need to go through and figure out the slope of AB and then the slope of DC. So for the slope of AB, we're going to use the vertex points of A and B for our x1, y1 and our x2, y2. So A is our x1, y1. and b is our x2, y2. So we're going to use those points and we're going to plug them into the slope formula, so y2 minus y1 over x2 minus x1, to figure out the slope of AB. So y2 minus y1, so that's going to be 3 minus 1 over x2 minus x1 is going to be 2 minus a negative 1. So now we have 3 minus 1 over 2 minus a negative 1. We just need to go through and simplify the top and then the bottom. So 3 minus 1 is going to be 2. And then 2 minus a negative 1 minus a negative turns it to positive. So 2 plus 1 is going to give us 3. So I now have a fraction of 2/3. Before you call it good, just always ask yourself if you can simplify it any further. In this case, we cannot. If you could, you would need to go through and simplify it as far down as you can. So 2/3 is as simplified as we can get, and that is the slope of AB. So we now have found the slope of AB. We next need to find the slope of DC, and if those two are the same, then we know the lines are parallel, thus giving us a trapezoid. So for DC, we're going to use the points 3, 1, and then -3, -3 to find our slope. So it's y2 minus y1, so it's going to be -3 minus 1, over, then it's x2 minus x1, so it's going to be -3 minus 3. So we have -3 minus 1 over -3 minus 3. For the top, -3 minus 1 is going to give us -4. And then -3 minus 3 is going to give us -6. So we now have -4 over -6. The question you need to ask yourself is, can I simplify this down? So 4 over 6. 4 6 will simplify down to 2/3. And if we have negative over negative, two negatives make a positive. So instead of a -4 over -6, this is going to be a positive 2/3. And that is the slope of DC. So the question I ask you, are the slopes of AB and DC the same? They are, because they're both 2/3. And because we know that they are both the same, that means AB is parallel to DC. So same slope. Means that AB is parallel to DC. And that is our answer for example 1, part A. So if you're doing it with a trapezoid, you just need one set of opposite sides to be parallel. The homework's going to really guide you through that because you just have to fill in for each blank what the slope is of, say, AB and then the slope of DC is. So you don't have to go through and figure out which ones need to be. The homework will guide you through that. So that is one way that we can go through and figure out the slope of both of the lines and then determine if they're parallel. For example 1b, I'm going to show you the other method of determining the slope of a line. So let's go ahead and move to part B for example 1. And part B is going to ask us to show that PQRS is a parallelogram. In parallelograms, we have opposite sides are parallel. So that means PQ needs to be parallel to SR, and that PS needs to be parallel to QR. So we need two sets of opposite sides to be parallel to each other, not just one set. Now, for example 1, part A, all I had us do was use the slope formula, y2 minus y1 over x2 minus x1. If you feel comfortable and you like using that method, by all means you can continue to use the slope formula. For part B, I'm going to use the idea that slope is rise over run to help us answer this question. So instead of using the slope formula, we're going to use the graph and counting how much we go up or down and then left or right to get to each point to figure out the slope of all of our lines. So let's go ahead and jump into this. We need to figure out if PQ is parallel to SR. So let's go ahead and figure out the slope of PQ. Now, instead of using y2 minus y1 over x2 minus x1, we're just going to use rise over run. If we ever go up, that is a positive direction. Going down is negative. To the right is positive, and to the left is negative. So to figure out the slope of PQ, we need to figure out our path from P to Q. So how much do we go up or down, and then right or left. So to get from P to Q, we're going to go down 1, 2, and then to the right 1, 2, 3, 4. So we went down 2, so our rise is going to be negative 2, and then we went to the right 4, so we ran positive 4. So our slope of PQ is negative 2 over 4. Negative 2/4 is going to simplify to negative 1/2. So the slope of PQ is negative 1/2. Next, we need to look at SR to figure out if these two lines are parallel. So to get from S to R, we're going to go down 1, 2, and then to the right 1, 2, 3, 4. So we went down 2 to the right 4. So the slope of SR is also negative 2/4, which also simplifies to negative 1/2. However much you go up or down is on the top. However much you go right or left is going to be on the bottom. So we went down 2 to the right 4, and we simplified it to negative 1/2. So at this moment, do we know that PQ and SR are parallel to each other? We do, because PQ and SR have the same slope. So that means PQ is parallel to SR. Now, I would love to say that that is it and that we would be done, but because we're trying to prove this is a parallelogram, we have to prove that both sets of opposite sides are parallel. So we've accomplished in saying that PQ is parallel to SR. Now we need to say that PS is parallel to QR. So we need to figure out the slope of PQ and then PS and then QR for the next part. So PS and QR is what we're going to find the slope of. If we look at PS, so we have to figure out from P to S how much we go up or down, and then left or right. So from P to S, we go down 1, 2, 3, 4, and then we're going to go to the right 1, 2. So we went down 4 to the right 2. That's going to be negative 4 over 2. Down 4 to the right 2. Negative 4 over 2 is going to simplify to negative 2. So the slope of PS is negative 2. Now for QR, we start at Q to go to R. We go from Q, so we go down 1, 2, 3, 4. And then from this point, we're going to go to the right 1, 2. So we went down 4 to the right 2 for QR. So our slope for QR is also negative 4 over 2, which results in negative 2. So, knowing that, are PS and QR parallel to each other? They are because, again, they have the same slope. And because they have the same slope, we know that these two lines are parallel. So PS is parallel to QR, thus telling us that PQRS is a parallelogram because the opposite sides are parallel to each other, and we have two set of parallel sides. Trapezoid only requires one. Parallelogram requires two sets. So that is how you do example 1. Now I do have parts C and D where you would just run through the same thing. For part C, we have JKLM is a trapezoid. Because it's trapezoid, all we need to show is that JK is parallel to ML. If we can prove that those two lines are parallel, then we know we have a trapezoid. Now D is going to be a parallelogram, so you'd have to do it much like B. I am going to leave parts C and D for you to do on your own if you would like, to give yourself some extra practice. As always, they are done on my completed notes, so you can always reference my work there to see how I did C and D, to see if you're on the right track, or if you feel comfortable with it. So, you can either use the slope formula, y2 minus y1 over x2 minus x1, or you can use the concept of rise over run to find your slope to answer your question. So, that is example 1 for today. All we have left is example 2. Now, example 2 for 10.1 is going to ask us to find the coordinates of the missing vertex in each parallelogram. So for example 2, every shape is going to be a parallelogram, and we have to go through and find the missing coordinate. So for part A, we have A, B, C, D, and they give us the vertices of A at 1, negative 2, B at negative 2, 3, and D at 5, negative 1. So they give us the points, or 3 of the points, and we have to find the missing point, which in this case would be C. So our goal for the notes is to first go through and plot the points. On the homework, they will have already plotted the points for you. So A is at 1, negative 2. B is going to be at negative 2, 3. So we go back 2 and then up 3. And then D is going to be at 5, negative 1. So our points are going to look like this. And then to kind of set it up like how the homework is going to look, they will also have the lines drawn for 2 of these spots to kind of help guide you. All right, so we have 2 sides of our parallelogram and we have 3 of our points. We need to go through and find where C is going to reside in this area that results in a parallelogram. So the way that you're going to do this is we're going to use slope to help us figure this out. So our goal is to figure out the slope between points A and B, and we're going to apply that slope, what it took to get from A to B, to then apply that to D to figure out C. So if we look at B, or how we get from A to B, to get from A to B, we're going to have to go back 1, 2, 3. So we go to the left 3, and then we're going to go up 1, 2, 3, 4, 5 to get to B. So we went to the left 3 and then up 5. So from A to B, we went back 3 and then up 5. We're going to apply that slope to D to figure out where C resides. So from D, we're going to go to the left 3, so back 1, 2, 3, and then we're going to go up 5. So up 1, 2, 3, 4, 5. And that point right there is going to be our point for C that results in parallelogram. So if we want to figure out the coordinates of our missing vertex, C is going to be at 2, 4. And that is our answer for example 2, part A. So your goal when you get to these problems is to go through and find the slope between 2 points and then use that slope, apply that slope to the third point to help you find the missing fourth point. So let's go ahead and do one more. For part B, we have PQRS, and they tell us the vertices for P are at -3, 0. And then Q is at -2, 4. And then R is going to be at 2, 2. So PQRS, so S needs to be in this area right here. That's our missing coordinate, and that's what we're going to figure out. So I'm going to draw half of our parallelogram real quick. So we need to figure out where S is going to be at. What I'm going to do is figure out the slope between P and Q, and then we're going to apply that slope to R to figure out where S resides down here. So to get from Q to P, we go back 1, and then we go down 1, 2, 3, 4. So we go to the left 1, and then we go down 4. So we're going to apply that path to R. So we go to the left 1, and then we go down 1, 2, 3, 4. And that's going to take us to our new point. And then the coordinate value of S is going to be at 1, -2. And that is our answer for part B. And that is how you go through and do example 2. Now, parts C and D are going to be very similar to what we just did in parts A and B. So you would go through, find the slope between 2 points, apply that slope to the third point, and then that will take you to your new location of the missing coordinate. Now, like example 1, I'm going to leave parts C and D for you to go through and do. Again, they are done in my completed notes if you would like to look at them for guidance or see if you are on the right track. As always, with parts C and D for examples 1 and 2, if you have any questions or would like me to run through them, just let me know the next time you see me or shoot me an email, and I'll be more than happy to help or answer any questions that you may have. So, to wrap up 10.1, remember, the slope of parallel lines have to be the same. If 2 lines have the same slope, that means that those 2 lines are parallel. Trapezoids require 1 set of sides to be parallel. Parallelograms require 2 sets of sides to be parallel. So, with that said, that is it for today's lesson on section 10.5, proving the slope criteria for parallel lines. And I appreciate you guys taking the time to listen. If you have any questions, as always, let me know, and I'll be more than happy to help. So, have a great day. Thanks for listening, and I will talk to you guys later. All right, bye.